This is the last video in the 4-video series on the x-intercepts of the quadratic function, and I'm going to show you how to derive the quadratic equation here. So you can see exactly where this negative b squared minus 4ac thing came from. So we're going to start off. And we want to know, when is this thing equal to 0? For which x values is this equal to 0? So for which x is this true? And the motivation behind this, the motivation is the following. See, if this were x squared, if this b term weren't here at all, if this was ax squared plus c, it's pretty easy. b equals 0, then ax squared plus c is the equation equal to 0. Well then, x squared is negative c over a. Move the c over to the other side, picked up a minus c, and then divided by a. So then x is plus or minus the square root of c over a. That's pretty easy. Oops, and there's a minus sign that I lost. You might say, is that negative? Well, maybe. If c or a is negative, then you're in good shape. But let's see here. It's not normally the case, but what does this look like graphically? What it looks like graphically, here's x, here's y, is it's a case that looks kind of like this. It's a case where the vertex is in fact in line with the y-axis. So you get these two roots here, or perhaps just one or none. And this is the case where a is greater than 0. Of course, if a is less than 0, you just flip everyone upside down. So this is no roots. That's the situation where negative c divided by a is negative. Here's the situation where c is equal to 0. So this is the c equals 0 case. This is minus c over a is negative, and this is minus c over a is positive. Those are those three possibilities. Now, this is really the easiest situation. But now what if this axis were moved? Well, we could put this problem back into the situation, into a situation where we can solve this, we can move that axis. So let's just move the axis by renaming and writing down a different variable. Let's introduce another variable. So instead of doing x, we're going to temporarily work with z. So introduce a new variable, z, using the equation x is z minus, well, where's the axis? The axis, or rather z plus, where's the axis? It's negative b over 2a. So remember, this is the axis of symmetry. We're moving symmetry. So what we're doing is we're moving the axis of symmetry around. It'll still be the same place in the x variable, but when we move it over into the z variable, we'll write this out in terms of a z variable equation, it'll be, that axis will be moved in line with the y-axis. So, and we can see that algebraically. So let's substitute in this for x. Our original equation becomes what? 0 is a z minus b over 2a squared plus b z minus b over 2a, and the c is left alone. Okay, well, let's do out the squaring here. Let's, as they say, FOIL it. Let's see, so I should get a 2b over 2a z plus b squared over 4a squared. So I foiled this guy. This one here I'm going to distribute the b through. Times, this is a b squared. I've got two b's over 2a. Okay. Now I'm going to distribute through the a. So we get a z squared minus 2ab over 2a times z plus ab squared over 4a squared plus bz minus b squared over 2a plus c. Okay. Now, let's see here. We can do some canceling. I see a 2a over 2a right here. Gone. I see here an a over an a. One of those a's cancels out. So let me write what I've got here. And, oh look, there's more canceling I can do. I've got a BZ and a BZ. They're gone. And so this is now what? A z squared. And look, there's no z's in these remaining terms. In fact, this term here, what is this one? Well, it's like 1/4 minus a half. So what's that? It's negative a quarter. So this is minus b squared over 4a plus c. Okay, so we've written this down, and if you look at it, this is now something all on its own that if I look at it and say, oh, wait a minute here, that bz term is not there, and this bx term is here, it's gone. So we've successfully shifted that axis of symmetry when we write it in terms of these z's, so now we can just solve outright. So let me move this equation up. And actually, we're going to keep this statement over there. 0 is a z squared minus b squared over 4a plus c. Okay. So now let's solve for z. So let's see here. What am I going to do? I want to solve for z, huh? Well, how do I do that? Well, I guess I move all this stuff over to the other side. So I get a z squared is b squared over 4a minus c. Okay, let's put this on a common denominator. It's b squared minus 4ac divided by 4a. Hey, look, there's the discriminant. The b squared minus 4ac showed up. Okay, now I want to divide through by a. Now I'm going to square root the z. And when I square root that thing, what am I going to get? Well, I'm going to get plus or minus square root b squared minus 4ac, just as we wanted. And what's the square root of 4a squared? Well, the 4 square root of 4 is 2. Square root of a squared is a. Okay. So that's what z is. But now we're really interested in x. The only difference between z and x is this axis of symmetry. So let's put it back in. So x is what? Oh, look, there's a common denominator of 2a, just as we wanted. So we can just write it out in the way that you're used to seeing it. Success. And that's how you get the quadratic equation.